Hey guys, happy Monday. Almost there into Christmas break. We just got a couple more to get through here. The good news for you guys is we do not have any midterms. So your grade is just going to be 50-50 split over the first quarter and the second quarter. So if you want to start messing with what what your grade to get to, you can take your first quarter percent, half of that, and then figure out what you need to get to wherever you want to be. You can kind of mess with that a little bit. What we're gonna do here before Christmas is we're gonna do just a brisk run through Unit 5. We're not going to test over Unit 5. It's just some stuff that I want you to see in case it shows up on your air test. I think that it's kind of like not as important maybe. As what I'll say. And then when we get back from Christmas break, we're going to really jump into some heavy-duty information for our class, some really important stuff. So today we're just going to really quickly talk about the absolute value function. So absolute value, we talked about it earlier this year when we solved absolute value equations, right? It's going to turn everything into positive numbers. So for example, if I had the absolute value of 6, it's just 6. How far is 6 from 0? It's 6 away. How far is negative 12 from 0? It's 12 away, right? So no matter what we put in there, we're going to kick out a positive version of that number. So we're going to look at a series of functions here. In Unit 5, Unit 6, Unit 7, we're going to talk about some different stuff, okay? So the absolute value function would be something like, what do you think this would look like? Thus far, we've kind of dealt only with stuff that's linear, right? We've solved systems of linear equations. We have graphed linear functions. We've done a lot of linear stuff. We're going to deal with a lot of non-linear stuff for the rest of the year. And this one right here is not going to be linear. So just like every other kind of new thing that we learn about, let's look at a table of values and see what we think that's going to look like. All right, so it's always good to kind of have some negatives, some positives, and 0. That'll give you kind of a good picture of what's happening. So I usually go from -2 to 2. I think that's a pretty good window. And just kind of, we're going to plug that in, see what we get back out, and then maybe what we'll do is we'll graph it and see what it's going to look like. And then we'll talk about kind of some ideas about that, okay? So if I plug -2 in here, the absolute value of -2 is going to pop out +2. If I plug in -1, the absolute value of -1 is going to be +1. If I plug in 0, the absolute value of 0 is going to be 0. If I plug in 1, the absolute value of 1 is 1. And if I plug in 2, the absolute value of 2 is 2. Okay, so let's look at that on this very small graph I'm going to use. So -2, 2 is right here. -1, 1, 0, 0, 1, 1, and 2, 2. So if we take a look at this function, you can see that it is going to look like a V. Now think about what's going on here. If I take the absolute value of all the x's, when I plug in for x, if I take the absolute value of that number, there's no way I could get anything down here in the y's for my output, because it's going to turn everything positive when it's just y equals the absolute value of x. That's kind of why we have this situation happening. All right, all absolute value functions are going to look something like this. Just it could shift, kind of like how we already talked about linear shifts. It's going to shift in very much the same way. We'll talk about that too, obviously. Not today though. But kind of the same idea, right? So it could go left, it could go right, it could go up, it could go down, it could flip, all sorts of stuff. So what do we need to know? We need to know a couple things. First off, every absolute value function has a vertex. Okay? The vertex is kind of like, in this case, it's 0, 0. You guys see this point right here? It's where it switches. It's where it goes from one side and goes to the other side. And a really good way to kind of define this vertex is that there is a vertical line of symmetry through the vertex. Now, if you are not, up on your geometry at all, let's talk about what that means. I could draw a line, a vertical line, that would cut this thing so that it would be symmetric. I could fold it, it would have an axis of symmetry. Okay? And if, in this case, it's the y-axis, in fact. So if I reflected this side over the y-axis, what's going to happen is those are going to line up perfectly. And that's really interesting because that's always going to happen in an absolute value function, is we're going to have this line of symmetry. So no matter what my v looks like, it could be wide, it could be really skinny, all sorts of stuff like that. If we can find where it starts being symmetrical, we can find the vertex of that thing. And that's going to be the point where all of a sudden, if we draw a vertical line through there, it's going to be symmetrical on both parts. So the vertex is a really important point for us. All right. We're going to deal with very easy ones today, and kind of not worry about it. But I just kind of wanted you to get this idea of the vertex. Okay? So, we have vertex. Yeah, we got that. So, what are we going to do? Good question. Sometimes we might have a number in front of that absolute value. Something like this. All right, and it's kind of a shift. More like a stretch. Okay? Usually we call this number a stretch. And if we look at, let's kind of deal with this the same way. Okay? So let's look at a table of values here and just see what's going on. So if I plug in -2 here, follow along with me here. -2, the absolute value is like parentheses, so we always have to do that part first. So the absolute value of -2 is +2. +2 times 3 is 6. Let's do that same thing with -1. -1, the absolute value of -1 is +1. 1 times 3 is 3. Plug in 0. The absolute value of 0 is 0. 0 times 3 is 0. Absolute value of 1 times 1, is 1. 1 times 3 is 3. The absolute value of 2 is 2. 2 times 3 is 6. So we can even tell in our table here, we can see where that vertex is, right? In this case, it's going to be 0, 0 again. What's wrong? In this case, it's going to be 0, 0 again because we see how it's symmetrical on both sides of the y values here. You guys see that? The x's are not always going to be symmetrical. This kind of only happens really when your vertex is on a 0. But we can kind of see that the y's are always going to be symmetrical. And so, if I graph this one, That's good enough. My vertex is here at 0, 0. I have the point -1, 3, and 1, 3. And I have the point -2, 6, and +2, 6. And so, as you can see, when we put this 3 in front of that, what's going to happen is it gets real skinny. And it's going to stretch it, it's kind of like someone pulled it up high. We're taking all of our numbers and we're multiplying them by 3. And so that's going to make this thing real skinny because it's going to go increasing at a quicker rate now. All right? And so if you kind of look, here's what our parent, we call y equals the absolute value of x. We call that the parent function. It's like the most basic of the absolute values. And kind of every single function has a parent function, right? Like, so a linear one might just be like y equals x, right? So if we look at what's going on here, here's the parent function in red. And the one we just drew with the stretch is in black. And you can see how it's skinnier, right? Yeah, kind of interesting. So that's kind of how a stretch is going to work. Now, let's talk domain and range real quick. If you notice the parent function in red, its domain, I could plug in any x to this red function, right? Y equals the absolute value of x. I could plug in any number I want for x. So my domain here is all reals, but my range is not, right? Because like we said, there's no outputs that are going to give me a negative. So my range here is going to be 0. All the x's, or I'm sorry, all the y's that are greater than or equal to 0. Y is going to have to be positive. Or if you want to think of it, 0 to infinity would be a good range, right? Those are the same thing. If we look at the stretch is not going to affect the domain or the range, which is really interesting, right? Because even though it's skinnier, I know it's still going to get to x equals -5 at some point. It's just going to take a lot longer to get there than it would have here. So my x's are still going to be all reals for the domain, right? From -infinity to +infinity are still, that's my domain. But my range is also not going to change, which is interesting, right? Just because it stretches and it goes up at a faster pace or a slower pace, which I'll show you in a second real quick, it's not going to change anything, right? It's really interesting. Now, if I do some other shifts, it might change the range around. But the domain of this thing, I'm always going to be able to plug any number I want in for x here. All right, so that's just something to remember. I told you I'd show you another. So if I put a big number here, it made it skinny. Can anyone out there think of how to make it wider then? I wish that you could talk to me. Obviously you can't. I would want a smaller number there, but not a negative number. That's going to be for a different day. We're going to use a fraction. So if I had y equals, we'll say 1/2 absolute value of x. Check out what happens with this table, right? So if I plug in -2, absolute value of -2 is +2. 2 times 1/2 is 1. Absolute value of -1 is +1. 1 times 1/2 is 1/2. Absolute value of 0 is 0. 0 times 1/2 is 0. And then I'm just going to assume that you can take my word for it now. This side's going to be symmetrical to this side, which is super nice, right? So that's 1/2, and that's 1. So if you look at what happens now when I graph this, -2, 1, 1, 1/2, 0, 0, 1, I'm sorry, that was -1, 1/2, 1, +1, 1/2, 1, or I'm sorry, I'm not graphing that right spot, there we go, and then 2, 1. Now my V is open wider. than the red one, right? So if this number is less than 1 in front here, but greater than 0, it's going to make this wider how it opens. And notice that it still wouldn't affect the domain, and it wouldn't affect the range, right? So that's a good intro, I think, to the absolute value function. That's enough. We're going to talk about shifts and some things like that. We're going to talk about some other crazy stuff of functions, but remember, this is good for your notes because we'll kind of review all this, but we're not going to take a test over this, okay? All right, I'll see you guys later.